Yeah. So in simple language, the meaning of units is SI units, CGS units, all these things you guys have already learned. Okay. So let's take any example. I'll clear the board for a second. The best example that I used to learn was velocity. The other day only I told you the story, as to how your classmates will learn this chapter. Fine, they will sit and mug up. The mugging up concept will work only for few of them if it is really important, but apart from that, will not at all work. So understand how to start off. Velocity, the units is always meter per second. This you will obviously know because of your 10th standard as well as 9th standard basics. Now, in 11th standard, you learn something called as dimensions. There are seven dimensions which are supposed to be learned, seven types basically. Fine. It'll be one will be called as mass, the other will be called as length, something will be called as time. There's also something called as current. Representation is A. Okay. So current, temperature, all these things are there. But most of the times, what we use to represent things in terms of dimensions is usually ML as well as T. This dimensions belongs to the units called as, is obviously related to units as well. Without units, there is no dimensions. Without dimensions, there is no units. This is how it works. Fine. Now, let's say, I'll tell you how to start writing the dimensional formula first for anything, and then we'll start off with the actual concept. See, understand, it is your duty to first find the units. Without the units, it is impossible to write dimensions. You'll have to have some reference to write dimensions, and in this case, the reference is units. So right now, since I wrote velocity, I understood that the unit is meter per second. Fine. So first, I'll blindly write MLT. Now let's try to decode the meaning of all these three letters. M always means mass of an object, all those things. L obviously means length, and T is time. Fine. So mass, length, as well as time is what is by default understood in terms of dimensions. Now, let's go back to the units. Unit says meter per second. Meter is always there to represent some sort of length. Okay. In this units, meter M has no power. No power meaning by default it is 1. So therefore, I write that 1 on the length part. Now what happens there is the common confusion, common mistake what people do. They see M in the unit side. They'll put 1 on top of M. Wrong. M in terms of dimensions is different. M in terms of unit is different. M in terms of dimensions means always mass, kgs. Okay. M in terms of units always means meters, some sort of length covered. So this is a common mistake which you guys should avoid. Just because there is a M in the units part doesn't mean you'll just go put one number M. You'll go put one number on top of M. Wrong. Fine. Now, again, this is the common mistake. Important to understand. Mistake. Now, I'll go back to the units. Meter per second was there. Meter represents some sort of length. So I'll put the number 1 on top of length. Guys, let's say the unit was meter square. Only meter square. And for what quantity will the unit be meter square? Area. Any kind of area it will be. So if I ask you what is the dimension of area, what you guys will do here is you'll write MLT. Fine. Where M represents mass, L represents length, T represents time. See, I know that I'm repeating this a lot of times. That is because until you guys get used to it. Because common mistake, as I told you, a lot of people do it. That they get tempted looking at that M. They'll be like, M1 is there. I'm going to put the same M there also. And I'll be able to get the answer. That's wrong. Completely wrong. Fine. So let's say for meter square, meter meaning some kind of length. In this question, it was area. It has the number 2 on top of meters. So I'll go put 2 on top of L. Fine. Now, the remaining 2 letters had nothing to do with the units. Nothing in math meaning 0. You're supposed to put 0 and 0. Fine. Now, if you ask me, sir, what if I ignore MLT and just write L2? Will I get marks? You will get marks. Fine. It is just that I am not used to this. It is just that I am not used to writing L to the power 2 and T to the power 1 separately. I am always used to writing all the 3 together. Fine. Doesn't mean you should always follow me. In this case, if you feel like writing M0, T0 is useless, you can ignore that. You will still get complete marks. Fine. Now let's say I'll talk about guys. This is not yet done. Okay, the first one is not yet done. I'll give you a few more examples. In 9th standard, you guys came across a concept called as linear momentum, which was represented by the letter P. Fine. The formula went like this. This is not the unit. This is the formula. They said it is always equal to mass into velocity given by the unit. Mass is kg. Velocity is meter per second. Okay. Should you look at the formula? Never look at the formula, even though it is useful. Never look at the formula for dimensions. Always stick on to one rule. Fine. Because a lot of times you will never know what the formula only is. For example, here I've just told area. It can be area of a circle, it can be area of a square, it can be area of a rectangle, it can be area of some random shape. You will never know. So if you always assume area of a circle, you will start thinking about pi r square. But end of the day, what is more important here is the units. Any area is always meter square. So I would always try to avoid using the formula and stick on to one thing called as the units. Why? Because the chapter's name only says units as well as dimensions. So keep this in mind. Now, kg meter per second is there. You blindly write MLT first. Usually all the things will get covered here only. Now focus. I start with the left hand side. It says kg. Kg always represents some sort of mass here. Mass meaning on dimensions, it is represented by m. So I'll put 1 on top of m. Okay. Now meter per second is there. Meter is always some sort of length. In this case, what is the length? I mean, what is the power of m? 1. So I'll put 1 on L. I did not do the mistake there. Got that? Now, it is about time. There is seconds, but the problem here is that second was there in the denominator. That is why it was called as kg meter per second. Getting it? So since the second was in the denominator, you will put 1, but you'll put a minus. That's it. So whatever is there in the denominator will always get a minus. Whatever is present in the numerator, it will be the same as it is. Now, I'll give you another example. Let's talk about acceleration. The unit is meter per second square. Blindly write MLT again. MLT again. Fine. Meter meaning some kind of length. Length meaning it's always L. On L, I'll put 1. But here it says meter per second square. I realize number 2 has to be on time. But since that second is there in the denominator, I'll put a minus next to t. Got that? Now obviously cross check because this m here has not yet been used. So actually cross check if you've skipped something. You've not skipped anything, which means you're right. There is nothing on m. So you put a 0. Fine. So you can either write it as m0 L1 t to the power minus 2 or straight to the point L1 t to the power minus 2. You'll get the answer. Got that? Now, the actual logic, what they tell here is, they tell m to the power 0, the answer is 1. No, therefore, you can ignore that. Correct. That's also correct. I'm nothing against it. It's just that I am not used to writing that. Fine. So, we'll fill the first one right now. Meter per second was there. So, on time, I'll put 1. But since it was there in the denominator, I'll put a minus 1. Fine. Don't write anything. We'll keep on solving a few more questions. These are the ones which are the most common ones. There are few questions which are not common, and there's one huge table in your textbooks if you guys have one, or your teacher might give you a huge table. Should you okay, in the note which I send you also, there'll be a huge table. Should you read that? I would say yes, but don't sit and mug up. For example, let's say the table has the quantity called as force. Think of a way. Force is Newton. Fine. So start writing dimensions for Newton. So that's my next topic. Let's talk about force. Okay. The problem with force is we always know force to be in terms of Newton. And if I write MLT, what covers N, I don't know. What covers N, I don't know. In this case, what to do? This is called as indirect quantities. That is what I've named it. There's no such thing called as indirect quantities. It's just that I've given it a name. Fine. Force, everybody knows the answer is Newton. It is just that we do not know as to how it works. Guys, 1 second. I'll come back to the screen. Yeah, 1 minute. Yeah, good. Force is always Newton. Now, the problem here is we do not know what is the quantity. I mean, in terms of meters or seconds or length, you do not know. So what you will do here is, only in this case, if it is an indirect quantity, try to recall the most easiest formula of that. Fine. So, for example, if it is acceleration, it is a direct quantity. It is a direct unit. You need not recall anything because you have the unit right in front of you. But for Newton, you do not know that Newton has how many meters in it, how many seconds in it, how many kgs in it. You might never know. So in that case, you will think about the quantity and you'll also think about the most easiest, okay? You'll also think about the most easiest, formula for the quantity. At this point of time, I can remember Newton's second law of motion, which says force is equal to ma. That is the easiest formula that I can remember. I'll write the formula. See, sometime while I told formulas are useful somewhere, here it is useful. Fine. So right now, ma is the formula. Mass is given by kgs. Acceleration is given by meter per second square. In other language, Newton is nothing but the posh way of telling kg meter per second square. I don't want the posh way right now. I'll stick on to the most basic thing. This I will be able to write the dimensions because it says kgs. Kgs meaning some kind of mass. Mass in dimensions is m. How many kgs here? 1. I'll put 1. Similarly, followed by it says meters. Meters meaning length. How many number here? 1. I'll put 1 on top of L. Now, second square. So 2 on top of T, but since it belongs to the denominator, I'll put a minus. So this will be called as indirect. Okay. The best way to solve indirect is to think of the formula, which is the most easiest. There might be 100 formulas for force, formula for force. Nobody cares. What you guys can remember is what matters. Now, if you see how I would remember here is I would not mug up force at all because I know F is equal to anyways MA, which I learned it somewhere in 9th or 10th standard. I still remember that. I write MA as it is, and based on mass, I write kg. Based on acceleration, I write meter per second square because I knew both of them. Now, whatever I derived, I'll write the dimensions based on whatever I found right now, not based on what they give. So in this case, this will be called as the indirect method. Okay, indirect method is always useful to, useful for a lot of things. Just like this. I'll give you one more thing. Let's talk about power. Fine. Now, for example, power is equal to fine. Power better than power. I think I'll talk about 1 second, guys. Yeah, gravitational constant. This will be asked more. Wait, gravitational constant is cap G. Cap G. First of all, what's the formula? I'll tell you. Formula basically is F is equal to G m1 m2 by r square. Okay. In this, they'll ask you what is the dimension of G. All these things are important questions for MCQs. So first of all, change the formula and write. So it will be G equals crisscross F into r square divided by m1 into m2. Okay. You crisscross, criss and cross. You're going to get some answer. But this right now is again my indirect formula. I don't know, but I can try anyways. Usually what happens? Force is given by Newton. Okay. R square means meter square divided by m1 into m2. M1 is mass 1, mass 2. Both are some sort of kg. So it will be kg square. Now there's one more problem here. This is correct. Till now it's correct. There's absolutely zero mistakes here. But the problem is with Newton again. With Newton, instead of writing Newton, what can I write? I can write kg meter per second square. Correct? I can write kg meter per second square. I'll write kg meter per second square dot meter square by kg square. So see what can be done right now. The second square is actually in the denominator. No, I'll write that dot second square. Now this meter into meter square gives you meter cube. I'll write that again. So kg was there as it is. Dot meter cube it became. Try simplifying this if it is possible. I can cancel 1 kg with 1 kg. And the new formula I got, the new unit I got is meter cube second square dot kg on the denominator. This is what I got for F. Sorry, this is what I got for G in terms of units. Now, based on this, I'm supposed to start writing the dimensions. Now, you can proceed without cancelling also. It will take a lot of time. It will waste a lot of time. And the probability of you getting the right answer keeps on decreasing. So what I did right now, Newton, again, this indirect, I did not know. Please don't sit and mug up Newton to be m1 L1 t to the power minus 2. Incorrect way of learning it. You should not do that. Okay. You should never sit and mug up telling Newton is m1 L1 t to the power minus 2. Today you'll remember, tomorrow 100% you'll forget it. Okay. So make sure you try to find one way. The way is using the indirect method. Now, you applied that, you could see a lot of things getting cancelled. After getting cancelled, you got the answer for G here. Based on whatever I'm boxing here, I'll try to get the answer in terms of MLT. MLT, basic things I write first. Now, on the numerator, I can see meter cube. Meter meaning some sort of length. In this case, how many number? 3 number. Done. Now, followed by divided by second square, it says, which means 2 on top of t. Perfect. But since it is there in the denominator, you'll put a minus. That's it. Now there's kg. Kg meaning it is mass. I'll put 1. But since it is in the denominator, I'll put minus 1. Okay. So this is a way, also an indirect method, is just that this has multiple steps to it. Because you do not know about F. You do not know about G also. But guys, understand the meaning of G is gravitational constant. The meaning of lowercase G is acceleration due to gravity. For this, the answer will be meter per second square, and you'll be able to write the dimension for this. Not a problem about this at all. But when it comes to cap G, careful. Fine. So all the if it is cap G and if it is taking so much time to get the answer, this will be for a 2-marker question. Okay. So very important. Should you show them the calculation? You should show. Don't write. I'll anyway send this to you. Fine. Next. I wanted to tell you one more thing. Torque. Torque is superb. It's been asked a lot of time. MCQs especially. Torque is again rotating force. Given by the formula force into perpendicular distance. Again, this is not the unit, it's the formula. Now, the reason I do not know the unit, see, if you guys are actually into automobile and all those things, no, you will know the unit for torque. It is Newton meter. Fine. If you do not know, you will at least know the basics of it. 1 minute, guys. What is all these things? Okay, peaceful. Torque is equal to force into perpendicular distance. Now focus. Force is nothing but Newton. Okay. Perpendicular distance is nothing but meters. Okay. Torque is represented by tau, not at all required. But again, I have a problem. I am not sure with Newton. Fine. Newton is kg meter per second square. Kg meter per, guys, instead of writing per, okay, I'll write in the denominator itself. Second square was there, meter was there, dot meter was there on top also. So this becomes kg dot meter square by second square. You blindly write mlt. Let's start filling. Kg, some kind of mass. How much in number? 1 in number. So 1 on top of m. Should I put a minus? Not required because the kg is present on the numerator. Cool. Next, meter square was there. Meter square meaning length on top of L, it will be 2. Fine. Next, time is second square, 2 here, but along with a minus sign. Getting it? Important. So this will be the dimension for what you call torque. The only suggestion that I would give you is when you're trying to do this, no, little careful, be cautious that you guys are actually solving a question. Else, what people do here is they tend to, keep doing whatever they feel like, and they tend to get wrong answers. Fine. Now, there's in physics, there's one more concept called as stress, which we'll be learning little later in first year. Okay. That concept called as stress is always given by the formula force by area. 1 minute, guys. Force by area or force upon area. Thrust also it's called as. Okay. Now, again, this is the formula of it. Force is given by Newton. Area is given by meter square. Newton, you're not comfortable, but you know the alternate. Kg meter per second square. And meter square was there already. M square and M gets cancelled. What remains? Kg divided by S square dot M remains. 1, 2. Fine. Now dimensions will be M, L, T. Kg is 1. So I'll put 1 on M. L is also 1. But I'll put a minus 1 because M is there in the where? Denominator. Meter is there in the denominator. Therefore, I put minus 1. Now, T is 2 to the power minus. I mean, along with the minus. Reason is because the second was there in the denominator. We'll solve few more and then we'll go to the next part. Okay. 1 second. Power. We skip power now. We'll do it right now. Power is equal to what they're asking. Okay, what's the dimension of power? Fine. So the unit is watt. But the problem is you do not know what's the meaning of watt. Fine. Formula for power is nothing but work done by time taken. Work done per unit time. Okay. Work done per unit time. But the problem here is work also I don't know. Similarly, but don't you think W is equal to F into S? Somewhere in first, somewhere 9th standard or 10th standard, work is equal to force into displacement. I write F into S divided by time. I'll try. Force, it is Newton, but I'm smart enough right now to write kg meter per second square. Kg meter per second square I wrote. Time was there in the denominator, therefore one more S as it is. Then in the numerator there was distance or displacement. Distance or displacement is again meters. So meter into meter gives you meter square. I'll write that directly. Okay, that's my answer. One more thing I can do. Second square into second gives you second cube in the denominator. Okay, that also you can write. So this is the unit for what do you call power? I check. You can't cancel anything. So I'll proceed to start writing the formula. Sorry, the dimensions. M L T I write. First it is kg. Kg meaning some sort of mass. Okay, mass meaning m with a 1. Meter square is there. So 2 on top of L. No minus because it's on the numerator. Time is 3, but minus right now because it was there on the denominator. That's it. Okay, so that will be the answer for power. See, so they'll ask you about watt. So that is also the dimension for watt. Is just that you did not know directly, but this one you'll get it as a 2 marker because you're going step by step. But that being told, this can also be asked as an MCQ. MCQ meaning it's only 1 marker. If they are try to ask you in terms of some random 2-marker question, it will be asked show the steps. But if they're asking you in terms of MCQ, you just have to take the right answer and come. The problem with this chapter in MCQ is all the 4 options will have the same letters, MLT, MLT, MLT. So what I would do here is, I'll see all the 4 options, will not observe it properly, will not. I'll just see if all 4 of them have MLT, MLT, MLT. Fine, cool. If everything is having the same thing, all the 4 of the same quantities, I'll start solving for power and try to get the answer. But that's how it works. Don't try to get confused with respect to the options basically. Now, dimensional analysis. From this part only, I told you a lot of marks will come. Analysis, LYSIS. Fine. I told you 3 things will be asked. First one is checking the correctness. They'll give you an equation. They'll ask you to check if it is correct. Okay. How to do it also I'll tell you. Very simple it is. Okay. In fact, all 3 are very simple. Okay. Next, converting one form to another. One form in the sense converting SI to CGS or whatever. Okay. Converting from one system to another. That will make more sense. One system to another. So they will be like convert the SI to CGS or CGS to SI. Okay. So this also will be asked. The third thing which will for sure be asked in dimensional is deducing the relation between it. Deducing the relation between. I'll tell you how it works. Huge questions these are. Okay. It will be like a comprehension. Fine. They'll give you 4 to 5 lines of data. Based on that data, you should start writing. But to be honest, it's fun to get this answer. Okay. It's actually superb. In fact, amongst all the 3, I see all 3 are important. The one which is interesting is the last one. The remaining 2, you won't find interest on. You'll be like, hey, anyways, you know the answer is right. So let's keep moving. Okay. So for the first one, let's, I'll give an example. How to check if the equation is actually correct. Okay. I'll give you a problem. This is a problem from your final exam. Okay. They will be like, check if the equation, because we saw this in the previous class, x is equal to v naught t plus half at square is correct. Is correct. Okay. Please follow the procedure here. It is, see, for example, first only I'll give you the hint. Look at the formula. Is this formula similar to you? Are you familiar with this? Yes. If it is familiar, you obviously know that the question is right. By chance, if I tell you x is equal to st plus half at square, you 100% know that the answer is wrong. You won't tell the answer is incorrect. You won't tell that. You will show them as to how it is incorrect. Getting it? So usually what happens in formulas, in equations which you are familiar with, you know the answer before, you're just trying to prove it to them. Just like this one. We know this answer is correct. It's just that I'm trying to prove. Again, even they know that. That is why they're trying to ask you the question. Now how to solve? Step number 1. Check how many sides are there here. Here, any equation will have left-hand side and right-hand side. In this case, left-hand side has how many parts? 1 part. And what is that? X. Find the dimension of X. So I'll write that. D of X. Dimension of X. First of all, what does X mean? X means some sort of distance. Distance is always given by what units? Meters. So I'll write meters there. And I'll write the dimension formula for this. First I'll write M, L, T. It says M here. M meaning length. Length is 1 here. T is 0. M is 0. I hope you guys got that. So we start with the left hand side. We understand the meaning of it. In this case, X meant distance. I write meters. I find the dimensions for it after writing the units. Similarly, on the right hand side, if you observe properly, there are two parts on the right hand side. The first part is V naught T. The second part is half AT square. Fine. First, what I'm going to do, I'll find the dimension of the first part on the right hand side, which says V naught T. Okay. Now, what does V mean? Some sort of velocity. Do we know the unit for velocity? Yes. What is it? Meter per second. 1 second, guys. My bad. I'll write it properly. Meter per second dot. Okay. There was time next to it. What is the dimension of time? Not dimension, unit of time, seconds. So M by S dot S is what my unit is. Don't you think I'll be able to cancel S and S? Obviously, it gets cancelled. Now, once that gets cancelled, what is remaining? M is remaining. I'll write the dimension for whatever is remaining. Now, if you ask me, sir, can we cancel that? Obviously, you'll have to cancel it. So it will be M0, L1, T0. Done with this. Now, out of, in right hand side, out of two parts, the first part got completed. Second part, D of half AT square. Now, see, guys, I'm not dumb enough to write the number there. Whatever is given, I'm printing the same thing in my answers. Okay, half obviously is a number. Numbers will not have any dimensions, so ignore it. Next comes what? Next comes AT square. Okay, AT square. A is nothing but acceleration. Acceleration given by the unit meter per second square. I'll keep a dot. Next follows time. Time square it is. Time is second. Square becomes second square. Can I get cancelled? Gets cancelled. Is equal to M naught L1 T naught. Now check all your three answers. Are all the three things same? Correct? If all the three things, okay, are same, then the left hand side and the right hand side is obviously same. Therefore, the equation is dimensionally correct. You should write that. Dimensionally correct. That's all. So this will come for a 2 marker. See the length of the question also. It is not that difficult also. Again, you should solve the way, the exact way that I'm doing it right now. So you should find the left hand side, right hand side, how many parts? Each part. Now you'll ask me, sir, there's a plus, no, you didn't add only. You can't add them like that. Because they are dimensions. It's like indices. Fine. Indices, what did we learn? By chance, if it is M0 dot M1, only then we add the powers. We add when? Only if there's a multiplication sign in between. Right now, it's a plus here. So no adding, no subtracting. Just proving here. Getting it? We'll solve one more. We'll solve one more question based on the same correctness of the equation. 1 second. I'm looking for one. Wait. Check. Okay, fine. Wait. Check if yeah, F is equal to mv square by r is correct. Now see, okay, fine. I'm not going to tell anything. We'll start with this. Left hand side, okay, fine. The equation has two sides. Cool. Left hand side as well as the right hand side. Now in this question, the left hand side has only one thing, which is force. So what I'm going to do, I'll write dimension of force. Okay. Force, you know, the unit is what? Newton. But I am not comfortable writing Newton. So I'll rewrite the Newton as kg meter per second square. Fine. Now can you find the dimension? Yes. I'll blindly write mlt kg mass, which means 1 meter 1 minus 2 of what time? Left hand side done. Right hand side, dimension of mv square by r. Let's go step by step to form, guys. This is r. Okay. mv square by r. M obviously means some sort of mass. So I'll put kg. Fine. V square says meter per second square. So meter per second square. Oh, wait a second. My bad. Okay, first of all, V is meter per second. Since it has a square on top of it, I'll put 2. Divided by R, meaning some kind of radius. Radius is again meters. Okay, this is my answer. But I can cancel meter square and meter. After cancelling, the answer becomes kg meter per second square. I'll write the thing for this. MLT first I'll write. Kg meaning mass M on M1. M meaning length How many in length? 1 in length minus 2. Now check. Are both of them correct? Then you will write equation is dimensionally correct. You know my handwriting, no? That's how it is. Dimensionally correct. Got that? This is how you guys check it. So basically, the first application we learned. Correctness we learned. Fine. 1 minute, guys. Cool. Writing is important. The equation is not correct, but dimensionally correct. Fine. I think we'll solve one more easy one and then we'll go to the next application. Check if the last one which we solved yesterday. V square minus V naught square is equal to 2AX is correct. That's the question. Again, same old procedure. Left hand side, right hand side. Left hand side, there are two parts. Okay, we'll solve both of them. Okay, so dimension of V square first. V is meter per second, but since there was a square, I put square and square. I'll write the formula for dimension formula for this. MLT, I'll write on meter square, there is 2, length 2. Time is also 2, but now a minus, nothing on M, so I put a 0. First part done. Second part, guys, don't get confused. I'm supposed to go part by part. Fine. So the next part is V naught square. Dimension of V naught square. Don't you think it will be the same? Because there is also some sort of velocity itself. Initial velocity. So it will be meter per second. But since there's a square there, 2 and 2 there. Now this becomes M0 L2 t to the power minus 2. Left hand side done. Right hand side. D of 2AX. I am writing 2 along with it. Only while adding the unit only, you will ignore that. Because numbers have no units. Now followed by that, what is there? A is there. A meaning meter per second square. Meter per second square. Divided by, into, not divided, my bad. X meaning some kind of distance. Distance is always represented by some sort of meters. So you put meters. So it becomes M into M, nothing but meter square. So the answer is meter square by second square. Same thing, M0 L2 t to the power minus 2. I had 3 parts. Are all the 3 parts correct? Yes. You'll tell it is dimensionally correct. That's it. Any doubt in the first application? Ask me right now. Any doubt in the first application? No. Sure. Cool. So out of 3, the first one is done. 1 minute, wait. This part is done. You should have taken already here. Next. Converting from one system to another is the next topic or next application. And I chose 3, no. One of these 3 only will come. Okay, but end of the day, even though if I don't promise that, you should still be able to do this because it's easy. Next is what? I'm supposed to conversion. Okay. Okay, fine. Conversion from one system to another. Guys, you might get confused in one step, but just focus for the next 5 minutes. Once you're able to understand one procedure for this, no, it's actually very simple. Fine. Now, how will they ask you a question? They'll be like, convert the unit of force. I'll write it for you guys. First question. Just focus here. Convert the unit of force from SI units to CGS. This will be the question. Okay. This also has procedure. Let's go step by step. Step number 1. You should know what is the SI unit of force. You should also know what is the CGS unit of force. I'll write it somewhere here. So SI unit of force is nothing but Newton. CGS is called as dyne. D-Y-N-E. For example, if it is length, it will be meters and centimeters. No, just like that. It will be Newton and dyne. First, focus. Okay. You're supposed to start assuming few things. Okay. Now, how will you assume? Oh, guys, I forgot one thing anyways. Before assuming, find the dimension first. Dimension of whom? Dimension of force. Okay. You'll write SI unit, CGS unit. 1 second, guys. Okay, fine. Of force. Force is nothing but Newton. I told Newton is not required. Kg meter per second. Kg meter per second square. I forgot already. Yeah, kg meter per second square. MA, no, that's it. Meter per second square. I'll write the unit dimension for this. It will be M, L, T. Kg is mass meaning 1, L1 minus 2. This you wrote. Fine. And there is one more thing, okay? In your colleges, they write it as M, L, T to the power minus 2. Even that is correct. Okay, because to the power 1 need not be specified, no? So instead of writing 1, they just leave it as M and L. It's completely fine. Absolutely zero mistakes. Now, you found the dimension of force. Careful. Once you find the dimension of force, take the dimension and go back to this step where you wrote SI and where you guys wrote CGS. So first you'll write SI and CGS, the unit. Then you'll find the dimension of it. Then take the same dimension and go back. Okay. Now understand one thing. Look at the question. Conversion was happening from SI to CGS. So first what they asked me was SI. So the number 1 belongs to SI. Number 2 belongs to CGS. This is important. Number 1 belongs to SI. By chance, if they ask me CGS to SI, then whatever came first will get the number 1. Okay, in this case, SI came first, so it gets number 1. What I meant. So what I'm going to do, I'll blindly write the same thing, ML T to the power minus 2 and ML T to the power minus 2, same on both the places. Because end of the day, both are forces only, no? Now focus. I told you right now, wherever, in this case, since SI came first, 1, it gets number 1. Where should you write 1? In the subscript. Why not on top? Because there's already power there. Okay. So subscript gets 1 here. So this becomes M1, L1, T1. CGS came second here. So M2, L2, T2. Got that? Without writing the numbers 100 times, without writing the numbers, 100% you guys will go wrong. Fine. So in other language, don't you think if I tell Newton, my bad. If I tell Newton, it is nothing but M1, L1, T1 to the power minus 2, correct? Check here. Newton, the same thing. In the same line, I'll write for dyne also. Dyne, what changes? M2, L2, T2 to the power minus 2. You write both of them separately and next to each other and put a and next to them. That is the final answer for Newton. That's the final answer for dyne. I'm supposed to convert them. Now see what's going to happen. Obviously, this is the thinking point. Think. SI unit is bigger or CGS is bigger? Obviously, SI is bigger. How many examples are there? For example, meter is the SI unit, centimeter is the CGS unit. Which one is bigger? Meter is bigger. We obviously know that 1 meter is equal to 100 centimeters. Correct? So, how do I know this? Because SI is obviously greater. So, understand, we'll follow the same logic here. Whatever is greater will have the left-hand side. So, I'll tell 1 Newton is equal to how much dyne? I don't know. That is what I'm trying to find. So, since I don't know, I'll write N dyne. In other language, in terms of length, 1 meter is equal to how many centimeters? Let's say you do not know. You write it as N centimeters. What am I supposed to find in this application? I'm supposed to find the value of N. That's all. Getting it as to how it works? Now, 1 Newton is equal to N dyne. I'm supposed to find the value of dyne here. Now, sorry. I'm supposed to find the value of N here. Nothing else. Now, this is the most important assumption. Always the hint here is SI unit will be bigger compared to the CGS unit. Okay, it will be N times bigger. So let's find the value of N. That's my whole agenda right now, to find the value of N. Now, in the next step, what I'm going to do, Newton is on the left-hand side. Do I know the dimension for this? Yes, here. I'll copy that. I'll write M1, L1, T1 to the power minus 2 is equal to, okay, fine, N into, I'll open brackets. Do I know the dimension for dyne? Yes, along with the numbers. M2, L2, T2 to the power minus 2. Oh, my bad, wrong bracket. Okay, T2 to the power minus 2. First step done. Again, to repeat, what am I trying to find? I am trying to find the value of N, correct? So keep the N on the right-hand side itself. Shift everything else to the left-hand side and combine them. I'll tell you what I mean by combining. Combining meaning, make sure all the M's are in the same bracket. L's are in the same bracket. T's are in the same bracket. So it becomes M1, L1, T1 to the power minus 2. I still haven't separated it. I'll do it. The M2 comes to the denominator. It becomes M2, L2, T2 to the power minus 2. You guys understand? In this case, 1 means SI. 2 meaning CGS. Very important. Fine. Now I'll separate them. I'll keep the n as it is, all different brackets. M1 by M2 in the same bracket. Leave some space, put a dot there because anyways it's into L1 by L2 in the same bracket. Careful for T. I'll write T1 by T2 whole to the power minus 2. Check if I'm correct. Because both of them are minus 2. I'll just make sure it is minus 2 to the whole bracket. I'm almost there. Now focus. Keep the value of n as it is on the right hand side. Don't change it. N as it is. Now, ask yourself a question. Left hand side, you have 3 brackets. Let's solve the first bracket. M1 meaning mass 1. 1 meaning what? SI. 1 meaning SI, guys. 2 meaning CGS. It's like telling the first bracket is asking us a question. M1 meaning mass 1. What 1 meaning SI? What is the SI unit of mass? That is the meaning of M1. Similarly, M2 meaning what is the CGS unit of mass? That is the meaning of M2. The same question I'll ask myself right now. M1 meaning what is the SI unit of mass? kg. I write kgs. Denominator becomes grams because what's the CGS unit of mass? Grams. Okay. Similarly, ask yourself that question. L1 means what? L1 is asking us a question. What is the value of what is the SI unit of length? Meters. L2 meaning 2 meaning CGS. What is the CGS unit of length? Centimeters. Time. Both are seconds. So I'll write S to the power minus 2. Getting it? Now if you see, I can cancel the S and S. In fact, the third box is giving me a hint. It is telling convert whatever is required. For example, I can't cancel grams and kgs like that because both of them are not the same quantity. So in the next step, I'll try to convert them into same quantities. How? Simple. 1 kg is how many grams? 1000 grams. I'll write 1000 as 10 cube grams divided by grams, G, into 1 meter is how many centimeters? 100 is 10 square. 10 square centimeter is by centimeter. Now what am I trying to do? I am trying to make the unit same on both the cases. Now second and second got cancelled. What is remaining? 1 is remaining to the power minus 2 is equal to n. I'll repeat this part again. The third box gave me a hint. S and S could get cancelled. So what I'm going to do, I'm going to make sure that I'm going to convert the remaining 2 boxes also in terms of the same unit. Do I know the answers? Yes. kg is 10,000. Meter is 10 square. I write that. Now if you see, I can cancel them. What and what? Centimeter, centimeter, gram, okay, whatever. Now see, what and all is left with? Guys, what is 1 to the power minus 2? 1 to the power anything is always 1. So this remains to be 1. In the first bracket, what's the answer I'm getting? 10 to the power 3. Second bracket, 10 to the power 2. Into 1 is equal to n. Now apply indices. N is equal to, bases are same, multiplication sign in between, so we add the powers. 10 to the power 5. Go back to the main equation where I assumed here, and 1 Newton is equal to n dyne. I'll write that again. 1 Newton is equal to n dyne. But now I know the value of n. 1 Newton is equal to 10 to the power 5 dyne. 3 marker for sure question. Okay. Steps, you got to get used to it. So first what do? We write SI units and CGS unit. Then we find the dimension of it. Once we get the dimension, we go back to this step and write the same dimension. But now you're supposed to separate them by giving it numbers. Whatever comes first gets 1. In this case, SI unit was getting 1. So I put 1, 1, 1 next to SI unit, 2, 2, 2 next to CGS. We are done. Now what's going to happen? I'll continue. I know that SI unit is always bigger. So therefore I write this box. 1 Newton is equal to n dyne. Okay. Then Newton's value I knew. Dyne's value also I knew. I'll start substituting it. But wherever the CGS is there, that n has to be there. Now what are you going to do? What are you going to do? Keep the n to the right hand side. Separate the other things. Fine. Once you separate it, it will become this step. Box the m's together, box the l's together, box the t's together. Next what? Think that this is the crucial step. Suppose to ask yourself a question. What is the actual meaning of M1? M1 means, M means mass. 1 is SI. They're asking us, what is the SI unit of mass, which is kg. M2 means, they're asking us, what is the CGS unit of mass? This is important, guys. This is very important. Fine. It was gram. So whatever I did right now, I'll do the same thing for all 3 brackets. Now then I realized the third bracket, S and S gets cancelled. This gives me an idea. I'll try to convert the other two brackets also in terms of same quantities. It's possible. 1 kg is 1000 grams. So I write 10 to the power 3 grams by grams as it is. 1 meter is 10 square centimeter. I write that. Fortunately, the centimeter got cancelled. Gram and gram got cancelled. Now what I'm left is with only numbers. 1 to the power minus 2 was a problem. But as I told you, 1 power anything is always 1. You write the answer as 1. The remaining two things were 10 power 3, 10 power 2, 10 power 5 becomes the answer. That's the answer for n. I go back to the initial box, what I assumed. I change the value of n to the 10 to the power 5 time. That's all. This will come for 3 marks. Okay. Will it for sure come? Will it for sure come? Okay. Usually they ask force only. That being told, whatever has been asked, you're supposed to get the answer. No telling. I mean, obviously simple, man. You can't get things wrong here. Fine. So, 1 minute, wait. I am finding one more question. But this is the most asked question. This is dimensionally correct. One second, guys. Okay. Okay, next, lovely, this question is, show that 1 joule is equal to 10 to the power 7 erg. It's a proving question. By end of the day, don't get confused. It's simple itself. Okay. Now, left-hand side says joule. Unfortunately, I don't know how to write the answer for joule, dimension for joule. Let's go back to the previous question. Let's see how we found. Okay. Joule was the unit. Unit for what actually? Energy, no? Energy, work, all these things is nothing but joule itself. Since it is there for work, I'll write a work here. I'm trying to find the dimension first. That's what I told you. Okay, guys, 1 minute, wait. First, I'll write SI here. Is joule in this case. CGS is erg. This is the question. I'm supposed to show that. Fine. Joule and erg, I'll write the dimensions. It's a dimension of what? Dimension of work. Work, I don't know the formula. Sorry, the units. It's joule, but I don't know the dimension of joule, but I know the formula. Force into displacement. Force is Newton. I won't write Newton. I'll write kg meter per second square. Kg meter per second square into S is meter. Instead of writing meter, I'll write meter square directly. Okay. To this, I'm supposed to write the dimensions. I'll write M, L, T. Okay. M, L, T. Kg is 1 there. So on mass it is 1. 2 on T minus, 2 on L and minus 2 on T. This is the dimension of joule. I'll write that here. M1 L2 T to the power minus 2. Same thing I'll write here. M1 L2 T to the power minus 2. The left hand side has SI here. So 1, 1, 1, 2, 2, 2. Done. Fine. Now what do I write? I write the relation. 1 joule is equal to N erg. I'm just supposed to find the value of N. And if I get the answer for N as 10 to the power 7, my answer is right. That's how you solve. Same. 1 joule is N erg. Okay. Now what are you going to do? For joule, what was the answer? M1, 1, L1, 2, T1 minus 2 is equal to N into, open brackets, M2, 1, L2, 2, T2 minus 2. Now what do? Keep the N on the right hand side. Shift everything to the left hand side. It becomes M1, 1, L1, 2, T1 to the power minus 2 divided by M2, 1, L2, 2, T2 to the power minus 2. Now, are we done? No, I'm supposed to separate them. Separate all the M's together, L's together, and T's together. So it becomes M1 by M2 to the power 1 dot L1 by, guys, separating this is very important, guys. 2, T1 by T2 to the power minus 2. Now, 1 meaning what unit? SI unit. 2 meaning what unit? CGS unit. What question is it? Is the first bracket trying to ask me? M1 means what? What is the SI unit of mass 1? Mass 1, sorry, not mass 1. What is the SI unit of mass? Kgs. Divided by, this is grams. Here, L1, SI unit of L is M by cm square this time. Cool. Here, seconds by seconds to the power minus 2 is equal to n. This is my hint there, that box. Okay. S and S gets cancelled, becomes 1, which means I'm supposed to cancel the remaining units also. For me to cancel, I'm supposed to make them the same. To make them the same, I'm supposed to convert the SI to kg to grams. Do we know? Obviously, 1 kg is 1000 grams. 1000 is 10 cube grams divided by grams into 1 here. 1 meter is 100 centimeters. So 10 square centimeters divided by centimeter to the power 2. This is nothing but 1 to the power minus 2 is equal to n. Centimeter gets cancelled. G gets cancelled. 10 cube into 1 is 10 cube itself. 10 square to the power 2 is 10 to the power 4 into 1 is equal to n. Multiply both of them. N is equal to 10 to the power 7. I'll go back to the same thing. 1 joule was equal to n erg. 1 joule is equal to 10 power 7 erg. Hence proved. Either this or the previous one will be asked. Unmute and ask if you guys have any doubts. I didn't know about work, therefore I framed the formula, then got it. Apart from that, same thing. Okay. We finished 2 applications. Third one I'm not doing today because it'll go over there. So what I was doing in today's class, give me 10 minutes. I'll forward this PDF to you guys on WhatsApp. Make sure that you guys practice this again because next class we'll finish up the 3rd application and this chapter is going to get over. That's it. Okay. But out of these 3 things, only one will come. No doubt in this. But if you don't practice it today itself, we'll for sure forget. Today I've covered for 5 marks. No, not 5. Yeah, 5 marks I've covered. Tomorrow I'll send you one more 5 marker. So 10 marks will come off. Getting it? So is this chapter actually worth 10 marks? No, it depends. If they want to ask you this conversion, they usually won't ask the conversion. They usually ask the other one itself. But end of the day, potential this chapter has for like 8 to 10 marks.
Yeah.
So make sure you guys remember it. Fine. So yeah, if you guys have any doubt, just text me right now. I mean, unmute right now and ask. If you guys have no doubts, you guys can leave. I'll send the PDF in another 5 minutes. Okay. I want to just 1 second. What happened?
So that 1 to the power minus 2, how is it just 1 again?
What is 1 square?
1.
Okay. 1 to the power minus 2. Can I write it as 1 by 1 square? Correct?
Yeah.
What is 1 square?
1, okay.
So 1 by 1, answer is 1.
Yeah.
Got it?
And in my college, they are doing this projectile motions. Remember that time, height, range? They derived it using some
Derived it. Okay,
crazy
fine.
graph they use.
They like it's common. I thought that is not there. They thought you, then I'll do it that way. I thought it'll get cancelled.
So
Sometimes they.
So that ut plus half at square is there, no? In our class, they are using u only. They aren't using v dash.
No. You should use V naught. They won't give you marks in final exam.
Sir, I asked one fellow if we can use v dash. He's like
V naught. V naught, not V dash. V naught.
okay, sir.
You will have to use V naught only. They won't give you marks in board exam.
Okay.
They have some weird logic for that, anyways. Okay. Okay, fine. See you guys. Bye. I'll send the thing to you in like 5 minutes. It's getting uploaded.
Sir, and that course, what you're doing, sir?
I didn't check yesterday. I had no time. It's recording. Hey. Yeah.
Sir.
Yeah.
Sir, so like I didn't take computers in 10th, no. So like, will it be difficult for
No, it's actually easier this time.
Easier.
In class, go. Don't miss class.
Sir, I didn't miss class and all, but I don't understand.
What are they teaching? Like, give me some concepts.
Sir, name I don't
Oh, yesterday.
I don't know, sir. Name.
Hey, yeah,
Sir,
are you
that.
kidding me? What is wrong with you? What are they doing, da?
Sir, wait. Sir, 1 second. Wait.
Sir, and my electronics paper you'll give, no?
You shut up and study, then I will see.
Sir, I'm studying. I mean,
That
I'm
is that
to
dip.
study, but I'm understanding in class.
And then, why do you want the paper?
Sir, I don't know what is coming. There's too much to study. Sir.
Sir.
1 second, wait.
Sir. Hello?
Wait, Dachinal.
You say that when he comes.
He's here and what he'll do.
Not what you do, your behavior. It's wrong.
That's what. Don't go to CMR. I told you. You'll be.
Correct. Chinal, yes.
Tell her faster.
Sir, this one encoding schemes and number system.
In which language? C or
Huh?
hey, you're learning Java, C, C++. What?
So that I don't know, sir.
You're encoding where?
The chapter name is encoding schemes and number
Correct,
system.
ra. Encoding schemes and numbers where?
Where means what?
No. Dheeraj, are you understanding what I'm trying to ask?
Yes, sir. Hey, he's asking which language are they teaching you, like Python, Java, C++.
You're encoding, Andre. From where?
Chapter name that is, I don't know. I said it.
Oh. Hey, okay, ra. You go sleep. Fine,
Sir,
guys.
I'll
See
ask
you. Bye.
someone else, sir.
Sir, tell sir electronics paper.
ಅದು ಮಾಡೋಣ ಬಿಡ.
At least tell me what to study. I'll study. That's the first paper for me. Tell.
Wait.
So when you'll keep offline class, tell sir.
Wait, I'm recovering.
What
Sir,
happened
don't
to
want
you?
offline, sir.
4 p.m. 4 p.m. only now. Yeah, 4:30. 4. Yeah.
Ninth graders you're taking online, huh?
So you took new people?
Oh fuck no. Hey, the thing was I was trying to headstand. Okay.
Okay, sir.
I headstand. I got the grip. Then
Yoga?
No, headstand yoga ಮಾಡುವಾಗ headstand ಮಾಡ್ತಾ ಇದ್ದೆ. I stood for like 2 minutes. Then that fell out. I mean, then I thought I'll do a handstand. I'll just jump like that. I jumped. I slipped. My wrist slipped, and I landed on my shoulder.
Oh.
With so much effort, with so much thing, I landed on my shoulder. ಅದು ಸ್ವಲ್ಪ ಹಂಗೆ ಎಲ್ಲ ಇಟ್ಕೊಂತ ನನಗೆ. In the sense, it's fucked basically.
How long did they give recovery time?
They are fucking telling 6 weeks, but it's almost fine right now. Let's see.
How many weeks are over?
1 week.
4-5 weeks already over, sir.
1 BT, I'll give. Shut up and cut the call. Bye.
Sir, now tell electronics, you tell, I'll go.
Hey, I'll teach. I'll tell Ra from what was important. Go.